In this video, we will look at writing equations of sine and cosine graphs, given a graph or given the information. First thing you're going to want to do is figure out your vertical shift line. That's going to be the easiest way to determine your amplitude, your starting and stopping points, and everything like that. So I'm going to take this purple pen. Now, best way to do it, if you look at a max and a min point, and count the distance in between, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your midline or vertical shift is going to be halfway in between. So if you count 5 away from either of those, 1, 2, 3, 4, 5, and put a nice little dotted line, or you can put a solid line going across. So having a ruler is helpful. And then you may even want to plot some of the critical points that might show up, because those are going to help you with determining a starting and a stopping point for a sine or a cosine graph. The scale for this is going by pi over 6. Okay, I don't have the best blue option. Let me hold this down and see if I can get another color here. No, I don't have another blue, so I'm going to have to do the light blue. Everything in blue is going to be the same for both your sine and cosine equations. So that's going to be your vertical shift, your amplitude, stuff like that. It's the positive or negative and the phase shift that's going to change. So our vertical shift here, if we look at the line it's going through, is going to be -3. Our amplitude, or our distance from our midline, is going to be 5. I'm actually going to put that in just for color here so you can see it. Now the period. The period is how long it takes to go through one cycle. I always like to use the sine graph to figure out the period. So I'm going to count the distance between that starting and stopping point. 1, 2, 3, 4. So it ends up being 4 pi over 6, which is the same as 2 pi over 3. And the nice thing about this is if I set it equal to 2 pi over b, you don't even need to cross multiply, because you can see that the b value is going to equal 3. So basically what's going to happen at this point is all of your sine and cosine curves are going to have the a, b, and d values. They're going to be the same. So what I might actually do is fill that in right away. Oops. Y equals 5 sine 3, and I'll leave a little bit of space and put a -3 out here. Then I'll do y equals -5 sine 3, again leaving a space, -3. I'm going to do the same thing for my cosine graphs. Space. Alright, so we're going to then just figure out some of our phase shifts. So I'm going to throw x's in each, and then we're just going to do plus or minus. So if I go up and look for a positive sine graph starting point, I can do right here, which is -pi over 3. I could even do here, which is starting a new cycle. But let's do the -pi over 3 as my option. So it would be plus pi over 3. And then for my negative sine graph, if I look up again, let's erase these dots. A negative would start here, and then it's going down from that point. So actually, I don't even need to write a phase shift there, it's just 0. So I can just put x inside here. Kind of left a big space for that, but I didn't want to give that away. And then for cosine, a little trickier. Again, let me erase this information here. Cosine, we want to start above or below the vertical shift line. So a great spot here. This would be a starting and a stopping point of a cosine cycle. You could use either as your phase shift. I'm going to use the -pi over 6. So we'll put in there x plus pi over 6. And then to get a negative cosine, we'll just go to the bottom. Pick a point down there. You could do this one, you could do over here. So I'm going to pick this one and have that minus pi over 6. So what you'll notice is all the other information stays the same. It's just the phase shift and then the positive or negative signs that are going to change about each of your functions. So when you go to do the next example, you'll be looking for those 3 pieces of information, and then the 4th piece is getting the correct phase shift.